Good morning to all. How many of you have joined? Let me check. So all of you have unit tests, right? Good morning, Sai Teja, Sanjay Kumar. So सबका unit test चालू होने वाला है Monday से, right? Okay. And I got to know that chapters like properties of fluid and solids is coming in that exam, right? Hana? So I have picked up some questions from some CBSE sample papers, right? So वो पढ़ लेंगे, that we will do today. We will not study anything new today. कुछ नया नहीं पढ़ेंगे, right? And we'll try to do this, those questions, right? Some questions are numerical also, numerical based. Some questions are descriptive based also. Okay, so we'll try to do those questions. ठीक है? Nothing new we are going to study. Okay, so let's start with the first question. Okay, I'll give you some time, like 2 minutes. Okay, 2 or 3 minutes. You try that question, then I'll explain the solution for that. Okay, chalo. So let's start with first question without wasting much time. This is the first question on your screen. Hold on. Oops, what happened? Okay, so this is the first question. Please read the question carefully. Simple question, not very difficult. Okay, and try. Then we will see the answers. So you will get 3 minutes for this question. 3 minutes. Okay, go on. And if you have any doubts also regarding any question, you can ask me in the chat also, right? Last 2 minutes. Last 30 seconds. Okay, any answers? कोई आंसर आया है किसी का? No issue. So देखो, question is very simple, right? If you have studied this chapter, then it is very simple. See, it is telling a solid brass sphere is initially surrounded by air. So some air pressure will be there, right? Which is 1 into 10 to the power 5 Newton per meter square. Okay, or 1 atmospheric pressure. The sphere is lowered into the ocean to a depth at which the pressure is this much. Means pressure has increased. Of course, it will increase. Ocean is having water. Water is more denser than air and will apply more pressure, right? The volume of the sphere in air is 0.5 meter cube. Okay, so the volume of sphere is 0.5 meter cube in air. By how much does this volume change once the sphere is submerged? So when the sphere will go inside the water, more pressure will be applied by the water, right? And that sphere will contract. Okay, it will experience more pressure and will like contract. So by how much does this volume change once the sphere is submerged? Modulus of brass as 61 GPa. So modulus is given, basically it is bulk modulus, right? What is bulk modulus? You people know what is bulk modulus? Bulk modulus. So it is the a measure of ability of a substance to withstand change in volume. Okay, when some compression is applied on all the sides. Okay, so bulk modulus se kaam hoga idhar, right? So if I write the parameters here, initial pressure, what is the initial pressure given? Initial pressure, that means in air it is 1 into 10 to the power 5 Newton per meter square. Then we have final pressure, which is of course increased final pressure, that is 2 into 10 to the power 7 Newton per meter square, right? Then we have a volume of sphere, that is equal to 0.5 meter cube. Okay, then we have bulk modulus, or I can write it here also. Bulk modulus is how much? 61 G, means gigapascals, right? So it is 61 into 10 to the power 9 pascals. Okay, now so bulk modulus किससे दिया जाता है? B. Like Young's modulus is given by Y, bulk modulus is given by B, which is equal to minus of delta P, change in pressure, divided by change in volume upon original volume. Okay, so what we need to find here, this is the expression of bulk modulus, right? Change in pressure, negative of change of pressure, divided by change in volume, divided by original volume. Original means initial volume. Okay, so if I talk about what we have to find here, we have to find volume change when the sphere is submerged. So volume change means change in volume is this one. So this we have to find. इसको पता करने के लिए just take this to the left side, okay, and rest of the things to the right side. So change in volume is equal to minus delta P upon, that V will bring upside, okay, into V upon B. Now put all the values, very simple question. So if I put all the values, change in pressure is how much? Always remember, change is final minus initial. Badlav, I have 10 rupees today, but in future I may have 1000 rupees. So what is the change? 1000 minus 10, that is 900 rupees, 990 rupees. Okay, so change is final minus initial. So final is 2 into 10 to the power 7 pressure minus 1 into 10 to the power 5 pressure divided by into volume. Into volume is also there. So volume is how much? 0.5. Okay, divided by bulk modulus. Bulk modulus कितना दिया है? 61 into 10 to the power 9 pascals. Now if you solve it, solving is your work, right? Answer will come as minus 1.6. I have already done this, that's why I know the answer. ठीक है? So this is the change in volume. Of course the change will be very less, है ना? That's why 10 to the power minus 4 का range में आ रहा है. Understood? समझ में आया? बोलो बच्चों. People on YouTube, have you understood how it is done? Then we'll move to the next question. Yes. Yes or no? I want some replies. Okay, Sai Teja. चलो अगले पे चलते हैं, right? So basically you have to remember the idea of bulk modulus. Bulk modulus is change in pressure, negative of change of pressure divided by change in volume upon original volume, right? चलो, let's move to next question. Again, 3 minutes. Time starts now. Of course, there will be an elongation, right? Steel wire is there, brass wire is there. They will elongate due to gravitational force or gravitational pull. What is that elongation? That is asked. So यहाँ पे very simple. You have to use Young's modulus. Okay. For those who don't know what is Young's modulus, जिन लोगों ने बिल्कुल पढ़ाई नहीं की है, it is force upon area upon change in length upon original length. So this change in length we have to calculate, right? It is stress upon strain. Longitudinal stress upon longitudinal strain. Last 1 minute. And this 5, which is written here, this means that this question is 5 marks. Okay, let's do the question करते हैं, right? This much time is enough. You want more time? चलो, let's come to the question. अब सब लोग question करना बंद. Look here. So there are two wires of diameter. Some diameter is given, right? So radius will be half, 0.125. So one made of steel and other made of brass are loaded as shown in figure. Okay. The unloaded length of steel wire is 1.5 meter. Steel wire, ये जो ऊपर वाला wire है, this is 1.5 meters and brass is 1 meter. Brass कितना है? 1 मीटर का. Compute the elongations of the steel and the brass wires. Elongation निकालना है. How much it will elongate, expand in longitudinal way. So if I talk about the steel wire and brass wire, both have the same type of like properties, right? So Young's modulus दोनों में use हो जाएगा. Young's modulus I have explained here. I will write it again and I'll show you what is Young's modulus. Young's modulus is the ratio of stress upon strain. Okay, stress is force applied per unit area. Okay, divided by what is strain? Strain is when you apply the force, the length will change, right? When you pull something, length is definitely changing. So what is that change in length? Delta L upon what was the initial length, that is L. So this is basically Young's modulus. Now in this question, we have to find change in length, right? So if I want to compute change in length, I can easily write delta L is equal to force into this L will go up, right? So force into L हो जाएगा divided by delta delta तो लिख लिया है, divided by Young's modulus. Okay, FL upon Y. So this is the basic formula that we are going to use. Okay, अब आ जाते हैं. Let's come to steel first. So if I talk about change in length of steel, भाई steel में कितना change, force कितना लग रहा है steel में, just see. This is the wire. This wire is pulled by one 4 kg block and one 6 kg block. So total weight of the wire, total weight on this wire is 10 kgs. 4 plus 6, 10 kgs downwards. So how much is the force? Can I say 100 newtons? 10 G? Yes or no? So force on steel wire. Again, this is a steel wire. This is pulling or keeping this 4 kg and 6 kg in their place. That means this 4 kg is pulled by 4G plus 6G, right? That is 10G. So 10G is the total force acting on this wire. So I can write 10G into length. Length of wire, steel wire is 1.5 meters. Okay. Ensure that all the units are in SI units. Okay. Now Young's modulus. Young's modulus कहाँ से आएगा? Young's modulus of steel is given. Okay, that information is not given, right? ठीक है, I'll write it here. That is my mistake. 2 into 10 to the power 11 Pascal ले लेते हैं. This is Young's modulus of steel. If I talk about Young's modulus of brass, Young's modulus of brass, it is 0.91 into 10 to the power 11 Pascal. Okay, so this is steel, this is brass. I'll close it. So these are the two data that were missing, right? Anyways, let's continue. So Young's modulus of steel कितना है? 2 into 10 to the power 11. That we can put 2 into 10 to the power 11. So when you solve this, whatever you get, that is the answer. एक चीज और missing है, that is area. Okay, यहाँ पे area नहीं लिखा है. into area. What is the cross section area? Cross section area is pi r square. Cross section area of the steel wire, pi r square. So I'll write pi r. What is the radius? Radius is half of diameter. What is diameter, sir? Diameter is 0.25 centimeters. So what will be radius? Radius will be 0.25 divided by 2 into centimeters को meters में करने के लिए 10 to the power minus 2 meters. Okay, we want every data in SI units. Okay, so pi r square, r is 0.25 upon 2 into 10 to the power minus 2 का square. So this is area. Okay, this is Young's modulus, this is F, this is L. So FL upon AY, right? When you solve this, इसको solve करने के बाद you will get answer as, I have already solved it, so I'll just put the answer here. It is 1.49 into 10 to the power minus 4 meters. Okay, put the value of G as 9.8. G को कितना लेना है? 9.8 ले सकते हैं. Approximately 10 also you can take. Okay, so this is the change in length of steel wire. 1.49 into 10 to the power minus 4 meters. Let's also find the change in length of brass wire. Again, same formula, FL upon AY. FL upon AY. Force on brass wire, very important. This is brass wire. This is block. ये block उससे लटका हुआ है. This block is hanging. So force on brass wire will be the block which is hanging, right? 6G. So 6G into length of brass wire is 1 meters divided by, we have area. Area is again same area. See here, 2 wires of diameter 0.25 centimeter. So area is also same. So area फिर से लिख देंगे 0.25 by 2 into 10 to the power minus 2 का square, pi r square ना, so pi r square. This is area. Okay. Then Young's modulus. Young's modulus is 0.91 into 10 to the power 11 pascals. Okay. So what is the answer for this one? I have again calculated for this one. It is 1.3 into 10 to the power minus 4 meters. Means in steel wire it is 1.49 into 10 to the power minus 4. In brass wire it is 1.3 into 10 to the power minus 4. So how much is the total elongation? What is asked? Compute the elongations of steel. Okay, total elongation is not asked. Separate elongations is asked, right? So I can write elongation in steel wire is 1.49 into 10 to the power minus 4 meters. Elongation in brass wire is 1.3 into 10 to the power minus 4 meters. Okay, so this is the answer. चलें आगे चलते हैं. Good question. Okay, good, not good question that much, but हाँ, formula based question. These type of questions will come in your unit test. Next. चलो. So here I have put up 4 questions. 4 question मैंने डाला है, which is theoretical based 1, 1, 1 and 2 marks question. Okay. So थोड़ा सा सोचो. I will give you for each question 1 minute is enough. So total 4 minutes you take. Okay. 4 minute लो. See the questions. First question ka you can write the answer in your copies. What is Poisson's ratio? What is its unit? Then what is ductile and brittle materials? Then write those in your copy. Okay, and check whatever answer I give to you. Okay, so 4 minutes are there for you. Go on. Okay, last 1 minute. 1 नहीं, 2 minutes. Sorry. Last 2 minutes. Okay, let's start the answers. Okay. So first question is define Poisson's ratio. Very important. Poisson ratio तुम लोगों को याद रखना है. Okay. Okay, so how we'll define it? There are many definitions. Okay, if it is given by your teacher, you can use that definition, or you can directly write. It is defined as the ratio of the change in width per unit width of material to the change in its length per unit length, है ना. अब इसका मतलब क्या है, ये तो याद करने वाली बात हो गई. दिस इज टू मेमोराइज इट. ओके, अब इसमें इफ आई टॉक अबाउट द लॉजिक इज वेरी सिंपल. ध्यान से देखना. Okay, so this was a rod. Okay, ये एक rod था. By applying some longitudinal strain, when I stretched it, so its width will decrease. This is decreasing, right? This is called lateral strain. क्या कहते हैं इसको? Lateral strain. So basically, what is Poisson's ratio? Poisson's ratio is equal to the ratio of this lateral strain. You know strain पढ़ चुके हैं. Change in length upon original length, right? Lateral strain to longitudinal strain. Okay, इसका मतलब ये है, right? Very simple. Okay, इसको ट्रांसवर्स स्ट्रेन भी बोल देते हैं. देयर आर डिफरेंट नेम्स. इसको क्या और बोल देते हैं? ट्रांसवर्स स्ट्रेन, एंड इसको बोल देते हैं एक्सियल स्ट्रेन. ठीक है. सो दिस इज ऑल अबाउट पॉइजन्स रेशियो, राइट? खींचोगे तो विड्थ कम होगा. उस विड्थ कम का रेशियो विद रिस्पेक्ट टू ओरिजिनल विड्थ divided by longitudinal strain means change in the length divided by original length in longitudinal direction. Basically it's called Poisson's ratio, right? Very simple. Let's move to next one. Ductile and brittle materials. Okay, so ductile material क्या होता है? What happens when you stretch some material after means for example, if I stretch steel and if I stretch, let's say sodium, okay. So agar sodium ko stretch karoge, sodium will break easily, but steel will little bit stretch and can increase its length. So basically I can say steel is a ductile material because it has more plastic, it can undergo more plastic deformation, है ना? So plastic deformation means it can elongate to a very long length. लंबा length तक उसको elongate कर सकते हैं. That means it is suitable for making some wires. Wires बनाए जा सकते हैं, right? You cannot make wires of sodium or potassium because they are not ductile, right? तो definition के लिए क्या लिखेंगे कि ductile materials, I'm writing it here, okay, short में लिख देते हैं. It is the ability of material, ductile. Ductile को क्या लिखेंगे? Ability of material to undergo large plastic deformations. When we'll study this chapter, I'll tell you everything about what is this plastic deformation. अभी थोड़ा सा समझ में आया होगा, है ना? What is plastic deformation? Means it can last longer when you stretch it. It will not break. Okay. Plastic deformation prior to failure. इतना ठीक है. Ability of material to undergo large plastic deformations, right? ठीक है. What are brittle materials? Brittle material तो बहुत simple है, right? If you give stress to a material and it breaks without any significant plastic changes, then it is brittle material. So I'll write it upside only. इधर ही लिख देते हैं ऊपर brittle material. When a material is stressed or subjected to stress, right? It breaks without significant plastic deformation. ठीक? Deformation, right? When a material is stressed or subjected to stress, it breaks without significant plastic deformation. ठीक है? चलो next पे चलते हैं. What is the next one? Next one is saying what? अच्छा, let's go to next page. So these are some of the definitions. You can just have a look. It is given in your books also, right? Next is what is Young's modulus for a perfect rigid body. Perfect rigid body. पहली चीज, what is Young's modulus? Young's modulus is force upon area, stress upon strain, that is change in length upon original length. It is saying what is Young's modulus for a perfect rigid body. Rigid body का मतलब क्या होता है? I have told you in laws of motion also when I started the chapter. What is a rigid body? Rigid body means body that cannot be deformed, okay, by pressing or expanding or trying to expand. If you apply any deforming force, it cannot be reshaped. That is basically what a rigid body is, है ना? For example, if you take any material, if I take this chalk and if I try to press it from both sides, it will break, but it will not deform. If it deforms, then it will not gain its shape back, right? So that is basically a rigid body. Okay, so a rigid body cannot be reshaped by applying any deforming force. That means the change in length is zero for a rigid body. Force लगाते जाओ, length will never change. If change in length is zero, that means Young's modulus is the ratio of Fi upon A into 0 into 1 by L. That means 1 upon 0 का form. or some value constant upon zero ka form, that is infinite. That means for a perfect rigid body, the Young's modulus is infinite. Understood? Because it will not change, it will not deform, and change in length is zero. Because change in length kabhi tabhi aayega when length is changed. If length is not changed, it means it is not deforming, not changing its shape, right? So Young's modulus is infinite. Let's come to last one, last question. Why do we prefer a spring made of steel and not of copper? The reason is very simple. If you try to make copper spring and if you try to make a steel spring, who has more Young's modulus? Socho zara. Who has more Young's modulus? If you don't know, steel has more Young's modulus. Okay. Jiska jada Young's modulus, I'll write it here also with a different color. So I can write Young's modulus of steel is greater than Young's modulus of copper, right? If Young's modulus of steel is greater than Young's modulus of copper, so for the same shearing strain, the stress or the restoring force developed in the spring will be more than the spring of made up of copper. So I can say that means restoring force of steel is greater than copper. अगर restoring force steel का copper से ज़्यादा है, then we can say the spring made up of steel will rebound back very nicely as compared to the spring made up of copper. So in other words, we can say that in copper it does not rebound back to its original shape, whereas steel comes back to its original shape, right? So again, the story is very simple. अगर हम स्टील का स्प्रिंग बनाए और कॉपर का स्प्रिंग बनाए, and if you press both, steel has more Young's modulus, steel has more restoring force because Young's modulus is directly proportional to force. Stress में आता था ना, force upon L. So steel will have more restoring force and it will come back or regain its shape. But copper, since it is having less Young's modulus, it is having less restoring force, it will not gain its shape back. So spring अच्छा कौन सा है which gains its shape back, right? Which is made up of steel. So these were 4 theoretical questions that can come in your exam, right? Understood all the 4 questions? चलें आगे. Shall we move to the next question? Okay, some questions from mechanical properties of solids. Sorry, liquids, not solids. Solids to kar hi rahe the, right? Chalo. So we will do this question. Okay. Please read the question. Again, you will get 3 minutes. 3 मिनट का समय मिलता है और आपका समय शुरू होता है अब. Go on. Not 3 minutes, 2 minutes only. Question is very simple. नाइस ड्राइंग ना. ओके, दिस मच टाइम इज इनफ. चले आगे. सो सी हियर, लुक, सब लोग देखें. ऑल ऑफ यू लुक हियर. दिस मच टाइम इज इनफ. टाइम्स अप, टाइम्स अप, टाइम्स अप. क्वेश्चन में बोल रहा है, there is a cylindrical jar. Okay, I have made that jar. See here, it is having a cross section area of 0.01 meter square and is filled with water up to height 50 centimeters, right? It carries tight fitting piston of negligible mass. Okay, what is the pressure at the bottom of the jar when the mass of 1 kg is placed on the piston? Okay, so there is a piston also, and which is tight fitting piston, right? So let's say this is itself the piston. Okay, so this is the piston. Okay, it is tight fitted. When 1 kg mass is put on this piston, this is 1 kg mass, right? What is the pressure of at the bottom of the jar? Okay, so the pressure at the bottom of the jar is due to weight of the column of water, right, which has a height of 50 centimeters, and the weight of the load, that is 1 kilograms. That is the total pressure at the bottom, है ना. वो कैलकुलेट कर लेते हैं. कैसे कैलकुलेट करेंगे? So I will write total force acting on the base. First of all, I'll write it downside. Hold on. Okay, so total force acting on the base is equal to, first of all, due to the height of the water, पानी की height की वजह से, what is the force? Have you studied rho h rho g? पढ़ा है तुम लोगों ने? h rho g, and area is a. H means height, rho is density of water, g is gravitational acceleration, and a is the cross section area. ओके, प्लस ये तो पानी की वजह से है. किसकी वजह से है? पानी, वाटर, H2O, and plus that 1 kilogram weight, that is due to 1 kilogram weight, that is mg. ठीक है, so this is the total force acting on the base. अब तो बहुत सिंपल कहानी है, right? Put all the values, you will get the answer. What is height? 50 centimeters. 50 centimeters मतलब 50 into 10 to the power minus 2 meters. Density, पानी का डेंसिटी कितना होता है? यू पीपल नो डेंसिटी ऑफ वाटर? 1000 किलोग्राम पर मीटर क्यूब. इफ यू टेक 1 मीटर क्यूब ऑफ बॉक्स, cubical box, you can fit 1000 kilograms of water. So 1000 kilograms per meter cube is the density. याद रखना हमेशा, density of water 1000 kilogram per meter cube. I have written also here. ठीक है, accordingly you can set per centimeter cube भी निकाल सकते हैं all into gravitational acceleration 10 ले लेते हैं. एरिया कितना दिया है? 0.01 and it's in meter square. Okay, fine. Mass is 1 kg, gravitational acceleration is again 10. If you solve this, you will get 60 60 newtons आया. Okay, so this is basically the force acting on the base. निकालना क्या है? What we have to find? Question में पूछा है pressure at the bottom. So pressure का formula is very simple. बचपन से पढ़ते आ रहे हैं ना. When we were born, from there we have started to study pressure formula. That is force upon area. Force is 60, area is 0.01. तो आंसर आएगा 6000 पास्कल. ऑप्शन ए इज करेक्ट. ठीक है, तो आज की कहानी यहीं तक रखते हैं। ओके, अच्छा एक क्वेश्चन और करते जाओ जाते जाते। ठीक है, सो दिस इज द होल सीन ऑफ दिस क्वेश्चन. डू वन मोर क्वेश्चन. Pressure P at any point fluid at rest is. Pressure P at any point in a fluid at rest is. बताओ बताओ बताओ. Tell me the answer quick. Pressure. Pressure. Force upon area when the liquid is still. अरे भाई जार में लिक्विड रखा है, right? It is still. So it is pressure is equal to force upon area. What is force? Which force? The normal force, है ना? So what is pressure in a fluid at rest? Normal force at that point per unit area. Okay. Sir, what happens if it is not in rest? If it is not in rest, or the case that fluid is moving, pressure in different directions could be different depending on the fluid acceleration in different directions. Okay. So वो एक अलग केस बन जाता, right? Okay. Correct answer. दिगंबर. Okay. Anyways, चलो अब जा रहे हो तो एक क्वेश्चन और कर जाओ, राइट? मेरी तरफ से. At large flow velocities, the flow of a fluid becomes viscous, turbulent, compressible, or laminar. So answer will be turbulent. Okay. So when any liquid is flowing more than its critical velocity, then the flow becomes turbulent. Okay. So इसका आंसर होगा turbulent. चलो, so इतना रखते हैं आज के लिए. Okay. From next week we will continue our topic that we were on, laws of motion. Okay. I hope your exam will be good. Go and prepare for your exam, but after attending all the classes, right? So this is it from my side. And if you have any doubt, you can ask now. 1 minute is more I'm giving to you so that you can ask your doubts. Pucho bhai, any doubt is there? Any other chapters doubt also you can ask. नहीं है? No doubt. What is critical velocity? अरे critical velocity नहीं पता. It is the limiting velocity in which the flow is streamlined. Okay. उसके बाद turbulent streamlined flow देखा है? Google पे डालना. Okay. If you have time, if you have access to internet, sometimes you can put on Google. Streamlined flow means very fine flow. No problem is there. It looks like that nothing is shaking or nothing is moving. Okay. Very fine flow from that hole will be. Okay, that is streamlined flow. अगर उससे ज्यादा वेलोसिटी हुआ तो फिर वो ऐसे 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 हिलने लगेगा. वाटर विल शेक. दैट इज कॉल्ड टर्बुलेंट फ्लो. ओके. सो क्रिटिकल वेलोसिटी तक स्ट्रीमलाइन फ्लो हो सकता है. आफ्टर दैट टर्बुलेंट फ्लो विल स्टार्ट. ओके. and the speed and the direction in which the flow of liquid changes from tube from smooth to turbulent is known as the critical velocity of the fluid. ठीक है. तो क्या होता है critical velocity? वो velocity जब streamlined flow से turbulent flow change होता है, that is critical velocity. Okay. critical. Any other question? कुछ और question? पूछो fast. Time's up. चलो, we'll discuss in the next class. Okay. अभी ये chapter अपन लोगों ने पढ़ा नहीं है, right? So I know you have so many questions in your mind, right? We'll discuss them later also. Okay. Abhi you go and prepare for unit test. Before that, you attend all the classes, right? Bye bye and happy Sunday.